All right, I want to present the answers for Geometry's Chapter 7 review. I'm going to do my work on a piece of lined paper sitting along next to this, so have your work next to you, and anything that needs to be changed or redone, make corrections on your work. In 7.1, the first problem that we're looking at here in 7.1, number 1, find the sum of the measures of the interior angles of a regular 30gon. Then find the measure of each interior angle and each exterior angle. So this is much like, in this problem we take, in order to get interiors, we take n minus 2 times 180. In the case of this, it's going to be 30 minus 2 times 180. So 28 times 180 is going to get us to 5,040 degrees for the sum of interior. Now it goes on and says find the measure of each interior angle. So if that's the case, each angle, if it's going to be regular, they're all the same, and 50/40 divided by 30 is going to get us down to 168 degrees for each interior angle. And it also asked for the measure of each exterior angle. No matter how many sides, the exterior sum is 360. In the case of this figure, we've got 360 then divided by 30 to tell me that each exterior angle is 12 degrees. So sum of interiors, each interior, and each exterior for number 1. Number 2, we're dealing with a 6-sided figure. If we've got n equals 6, then we're going to do 4 times 180 to find out that the sum inside is 720. The sum of the angles is 720. So for this one, for number 2, I've got 720, and I'm going to take away 120, 97, 130, 150, and don't forget to grab and take away that 90-degree angle. The 90-degree in the corner, you have to make sure you get that. And that whole subtraction problem, the 5 angles that are given, taken away from the 720 is going to tell us what that missing x is. So when I do the subtraction here, minus 97, minus 130, minus 150, minus 90, missing angle in number 2 is 133 degrees. Number 3. In number 3, we're looking at 1, 2, 3, 4, 5, 6, 7 sides. So I'm going to do 5 times 180 and find out that the sum of these angles is 900. Now, in this case, I actually have 900. Again, that's the sum. And there's different ways to approach these problems, but I'm just going to subtract away the angle measures that are sitting there. Minus 160, minus 125, minus 110, minus 112, minus 147. And whatever it is that's left is going to be equal to x plus 2x, those two unknown angles. So when I go and take all this away from 900, I'm finding out that there's 246 degrees between x and 2x. When I put together x and 2x, I get 3x. When I divide by 3, 246 divided by 3 tells me that x is equal to 82. All I needed to do was find that missing value. Now, in number 4, we're dealing with exterior angles. No matter what in exteriors, the sum is going to be 360. So I'm going to set a problem up like I've been doing. If I have 360, I'm going to take away the measures that I have written. 49 degrees is one measure, 33 degrees is one measure, and 83 degrees is one measure. Once I take those away, that's going to leave me with 7x plus 6x is. So 360 minus those 3 given measures is leaving me with 195 degrees for 13 x's. When I divide both sides by 13, I'm finding out that x is 15. So for section 7.1, they'll work with exterior, interiors, and our n minus 2 times 180 rule for interiors, and 360 for our exteriors. When we go on to numbers 5, 6, 7, and 8 in problem 5, This is a parallelogram, which means then that opposite angles are congruent. So in 5, I'm going to start by saying B is 101 degrees. And then I actually am going to use the idea that consecutive angles are supplements to figure out what A is. So A plus 101 is equal to 180 because angles sitting next to each other are supplements. When I take 101 away from both sides, I find that A is equal to 79 degrees. B is 101, A is 79. In number 6, I've got some side lengths and some angle measures in 6. Relating the side lengths, since it's a parallelogram, 18 is going to be equal to A minus 10. When I add 10 to both sides, A must be equal to 28. Relating the sides. And then I have opposite angles relation for B. B plus 16 equals 103. When I take 16 away from 103, I'm getting that B is, I think it's 87. Yeah, B is 87. In problem 7, since it's a parallelogram, I know that diagonals bisect each other. So in problem 7 then, I can set D plus 4 equal to 14 and C plus 5 equal to 11. Number 7, D plus 4 equals 14. And my other problem to solve is C plus 5 equals 11. When I take away 4 from both sides for number 7, I find out that D is equal to 10. And when I take away 5 from both sides in number 7 for C, I'm finding out that C is equal to 6. So the relationships between bisected diagonals here. Number 8 and 9 have to happen in the coordinate plane. I'm assuming you're coming to class with your graphs ready to go. Find the coordinates of the intersection of the diagonals. So the first thing that I've got to do is sketch in my diagonals. So I have a diagonal TR, and I'm interested in the midpoint of TR. T's point was at -6, -3, and R is sitting at 2 and 1. And to do the midpoint of TR, and we need midpoints figured out for both diagonals because we need to show mathematically that they're the same. Yep, they want the intersection of the diagonals, good deal. So my x values get added together. 2 plus -6 divided by 2. And my y values get added together. 1 plus -3 divided by 2. And when I do my mathematics and work down, 2 and -6 puts -4 over 2. 1 and -3, -2 over 2. So for TR, the midpoint is sitting at -2, -1. And my hope is that for the midpoint of TR, so this is TR's midpoint, when I go and do the midpoint of QS, I just need to mathematically show that it sits in the same place. So the midpoint of QS, you need to support your answer with midpoint formula. Q is sitting at -8 and 1. S is sitting at 4 and -3. When I add together the x values, -8 plus 4 divided by 2 is going to give me the x value of the midpoint. And then the y values, 1 plus -3 divided by 2 is going to give me the y value of the midpoint. -8 plus 4 all over 2, -4 over 2. 1 plus -3 all over 2, -2 over 2, and I'm looking again at perfect, just what I was hoping. The midpoint sits at -2 and 1. So the answer to my question is supported. What is the intersection of the diagonals? The intersection of the diagonals is sitting at 2, -2, -1, and I have evidence of that in the mathematics calculating midpoints. Now in number 9, 3 vertices of a parallelogram were given. They gave J, K, and L, and we need to find the M. And so I drew in the J, K, L, and then just looking at if this is going to be a parallelogram, then I'm looking to have a side that's parallel to J, K and congruent to it, and I'm looking to have a side that's parallel and congruent to KL. So one of the ways that I talked about this, in speaking with a student this morning about this, is looking at, well, if I've got to go and create a segment that's like JK, and I need to do it down here from L, kind of working a little bit, you know, backwards, maybe even counting like rise over run idea for the steepness of the line to help. But to get from K to J, I'd have to go up 1 and left 4. And that's the method that I'm using from L to figure out where this last point goes. Up 1 from L and left 4. And if I go drop that right there as my missing point, you know, and then I can pencil in, yep, it sure is looking like I've got my M in my right place. I've got these parallel to each other and congruent, parallel, congruent, and now I have these that are parallel to each other and congruent. So my M needs to sit at 2, -2 to finish that parallelogram for number 9. That wraps up 7-2 work. I need to get at 7-3, and the one thing that I'm doing as I turn my paper over to get at the 7-3 work is, I know in section 7-3, have your notes out if you don't already, is where I had the 5 ways to prove that a figure is a parallelogram. So in section 7-3, I need these 5 ways next to me, and let's go at what they're doing here. Let's see. Number 10. State which theorem you can use to show that the quadrilateral is a parallelogram. Well, what I see is I've got a congruent pair of sides, 8 and 8, I'm marking, and I have a congruent pair of sides, 7 and 7, that I'm marking. And when I look at my 5 ways to prove, this is way number 2, and it has to do with theorem 7.7 and the idea that I have both pairs of opposite sides congruent. Both pairs, opposite sides congruent. So the theorem is 7-7, but again, I'm most interested in the name. Now what I'm seeing in 11 is I've got no measure for the segments making up this diagonal, but I have measures here showing 6 and 6. So I'm looking at this as method number 5. It's that theorem 7-10 in our notes that show that diagonals bisect each other. Diags bisect each other. So knowing that justifies number 11 being a parallelogram. Now in number 12, I have one pair of opposite angles marked congruent, and I have another pair that's both marked 57 degrees, which makes those congruent. By theorem 7.8, I would show that I have both pairs of opposite angles congruent. Opposite angles congruent. And that's method number 3 from that chart in section 7.3. Now, number 13, find the values of x and y that make the quadrilateral a parallelogram. So then when I'm going in to do this, that means that I've got to find the values of x and y that I can say make opposite sides congruent. So for 13, I'm solving 4x plus 7 equals 12x minus 1. I'll come back to that in a second. And then my other pair of opposite sides is going to be y plus 1 equals 3y minus 11. And so in solving this, let me go to my solving for x problem first. You can tackle these multiple ways. I'm going to begin by taking 4x's away from both sides. If you started a different way, you should still get the right answer, the same answer I do. 12x minus 4x is going to leave me with 8x, bring down my minus 1. If I add 1 to both sides, 8 is equal to 8x. And to finish this, divide both sides by 8 and find out that the missing x value would have to be 1 in order for those side lengths to be equal to each other. I'm going to sharpen my pencil real quick before I solve the next one. If you haven't already done so, you could start solving this one by subtracting y from both sides first. And again, if you use a different method to start, you should still get the same answer as I do. 1 equals 2y minus 11. I'm going to add 11 to both sides. 12 is equal to 2y. I'm going to divide both sides by 2 and find out that the y value that makes those sides equal would be 6. Number 14. This one has to do with diagonals bisecting each other. So in 14, I actually just have one variable to solve for x. 4x would be equal to 6x minus 8. I would solve this by taking 6x's away from both sides. negative 2x equals negative 8. Go ahead and finish that. Divide by negative 2. Petty cord. Hi. And I'm on my prep and I'm making a video. Can I get back with you? Who are we talking about? Yeah, I don't have a lot. I'll come down when I'm done with my video. All right. Sorry about that. Divide both sides by negative 2. And x is equal to positive 4 to make those diagonals congruent to each other. Now, in number 15, 15 is also in a graph. One of the things that even after talking multiple times about showing that something's a parallelogram, I was still having some of you on your quizzes and things that we're doing not go through the process. Now, to show that it's a parallelogram, you've got to get at one of the 5 ways. You've got to get at one of the 5 ways. So in proving something's a parallelogram in the coordinate plane, we can show that both pairs of opposite sides are parallel, method 1, by counting slopes. And I think actually that's the method that I'd like to use. I'd like to count slope for z to w. The slope of z to w. Let's do rise over run. Up 1, 2, 3, 4, 5, 6, 7, 8. Up 8 to the right 1. The slope of z to w is 8. Now let me go do it for the x to y side because I expect the slope of x to y to be the same. From y to get up to x, what am I doing? 1, 2, 3, 4, 5, 6, 7, 8, and to the right 1. 8 over 1 is 8. I can mark these two sides as parallel because I just showed that their slopes are the same. Now when I go into, so again, that was the slope of xy, I counted as 8 over 1, said it was 8. The slope of ZW I counted as 8 over 1, said that was 8. Since they're the same, I can mark that they're parallel. If I'm going to do slopes and mark parallel on that, I've got to do slopes and see if I can mark parallel on WX. The slope of WX, I want to compare it to ZY. Up 2 to the right 3. 2/3 is the slope of WX. Slope WX, up 2, right 3. And come down here for ZY, from Z to Y, up 2, right 3. Slope of Z to Y, up 2, right 3. I can go and mark parallel lines on that pair of sides as well. So by definition of parallelogram, by definition, this is a parallelogram because I just showed both sides of, both pairs of opposite sides, P-A-R-A. Parallelogram. Both pairs of opposite sides are parallel to each other. Now in section 7.4, classify the special quadrilateral and explain your reasoning. The only thing I can get at here with number 16 is that this is a rhombus. And the reason I can say it's a rhombus, explain your reasoning, is I have 4 congruent sides. I wouldn't go so far as to say that this is anything other than a rhombus because the other option would be a square, and the fact of the matter is I'd need 90-degree angles and I don't have that. In number 17, this goes actually much like what I just used in number 15. This one's a parallelogram because by definition of a parallelogram, definition, I have both pairs of opposite sides parallel. Both pairs of opposite sides parallel. All right, now in number 18, I have the justification here. I can go ahead and say that this is a rhombus because all the sides are the same, but I do actually feel like because of these 90-degree marks, because all side lengths are the same and it makes it a rhombus is a parallelogram. And since a rhombus is a parallelogram, if I've got 90 degrees marked here, these two angles together should be 180. That would let me mark in 90 degrees here, 90 and 90, 180, 90 and another 90, 180. This is a square, and you need to make mention that all sides equal or congruent, and all angles are 90 degrees. So you have to go to those definitions to justify what's what. Now, number 19, I'm actually going to draw a little picture on my line paper for problem 19. It says find the lengths of the diagonal. If you don't have a drawing with this, add one because I want you to be sure. It's saying it's a rectangle, and the rectangle's name is WXYZ. It's telling me that WY, this diagonal, can be written as negative 2x plus 34. And then XZ, this diagonal, they're saying I can write that as 3x minus 26. And what we found out is that in rectangles, the diagonals are congruent. It's one of our theorems in section 7.4. So if I set these two quantities equal to each other, my approach would be to start by adding 2x to both sides. If you solved another way, you should still get this same answer when you're done. 34 equals 5x minus 26. When I add 26 to both sides, I'm getting 60 equals 5 times x. And when I divide 60 by 5, I find out that if x was 12, that I would have diagonals congruent to each other. No, it says find the lengths of the diagonals. My bad. I got to go back and use my 12. Now I've got to go back. Negative 2 times 12 plus 34. That's going to be the length of WY. That is going to be 10. And let's see, ZX should be 3 times 12, which is 36, minus 26. That also equals 10. Follow the directions and make sure you go so far as to tell what each of the side lengths are. Now, last but not least, for number 20, decide whether the parallelogram JKLM is a rectangle, rhombus, or square, and give all names that apply. This is another, whenever there's like explain yourself, give the names that apply, you've got to cover all the definitions, or all the aspects of the definitions. This appears to be a square. And if that's the case, then the first thing that I need to do is go and pull distance formula on all 4 sides to justify that the lengths are the same. Now, J is sitting at 5.8. K is sitting at 9.6. I'm writing these on here because then when I go to do distance formula, it's going to be more obvious what pairs I'm doing. And I need to just go around the entire figure, J to K. Put my X and Y values, 5 and 8, 9 and 6. We use our method of how far apart, and then I go drop in, so J to K is 4 squared plus 2 squared. That's going to be the square root of 16 and 4. It's the square root of 20. I'm going to move forward and hope that I keep getting square roots of 20 for each of these sides. J to K is square root of 20. Let me go to K to L. So now I'm looking at this side, K to L. And again, you have to have the evidence showing that these sides are all the same. How far apart? How far apart? I was hoping I had that 2 and 4 relationship. K to L is 4 squared plus 2 squared. That's also going to be the square root of 20. That's 2 sides. I got to keep going around. M to L. I hope it's square root of 20. Put my M, 3 and 4. My L, 7 and 2. How far apart? 2. How far apart? 4. There I am again. Square root of 4 squared plus 2 squared. Still getting square root of 20. So far, so good. Last but not least, M to J. M to J, I've got to show X and Y. M to J, 3 and 4, 5 and 8. How far apart? 4. How far apart? 2. There I am again. 4 squared plus 2 squared equals square root of 20. So because they're all equal to square root of 20, the first thing that I can say is specifically that this is a rhombus. I've got that. If I want to go so far as to say that this is also a square, which I think I can, I need to compare slopes so I can see if each of these angles are right angles. If these angles are right angles, my slopes of the lines are going to be opposite reciprocals. Now, as I go around this drawing, I'm going to try to do this kind of simply here. M to J's slope is up 4, right 2. M to J, up 4, right 2, reduces to 2. J to K's slope J to K's slope. To get from J to K, I have to go down 2, right 4. Down 2, right 4 reduces to negative 1/2. Those two are opposite reciprocals. That allows me to show a right angle here. Perpendicular lines have slopes that are opposite reciprocals. Now let me keep going around the figure. The slope of L to K, rise of 4, run of 2. So 4 over 2 would also reduce to 2. I can mark a right angle in this corner because this slope of negative 1/2 and this slope of positive 2 are opposite reciprocals. And then last but not least, from M to L, down 2, right 4, and down 2, right 4 reduces to negative 1/2. So I can also mark a 90-degree angle here. My last but not least, opposite reciprocals. This is a rhombus, and it's also a square because it's all 90 degrees. And actually, what was my last question? Is it also a rectangle? It certainly is, because it fits the definition of rectangle as well, that opposite sides are congruent. And we have 4 90-degree angles. The rest of your chapter review is due on Thursday at the start of class, and your Chapter 7 test is Friday.